Bismillahirrahmanirrahim. So today we'll be starting with the second lecture of Geotechnical Engineering 2, and we were discussing shear strength of soils. So previously in last lecture we learned that how shear strength for different soil types are generated, and then we looked at the direct shear test for the determination of shear strength. And we also discussed that there are certain other laboratory methods that are used in the field, or actually in the laboratory, to find out the shear strength of the soil specimen. So in that context, we start off with the second test, that is the triaxial compression test. We represented with the TXT. So what we basically do is that we will cast, or we can take an undisturbed soil specimen at any depth, okay, and we take 3 samples of the same soil, or actually from the same location, and then we run test on those specimens. So just to explain that, what I will do, I will make a soil specimen in a cylindrical form, and then we apply a compressive force on the top. So but in the triaxial testing, as the name suggests, we also apply a pressure, actually a uniform pressure from the sides, and we call that pressure as the confining pressure, sigma 3, and generally we call this vertical pressure as sigma 1 because it's the major principal stress and the pressure applied from the side is this sigma 3. Now the question comes to mind, how the confining pressure is applied on the soil specimen. So we can use different mediums. Some apparatuses use air for applying compression of sigma 3. Sometimes some apparatuses may use water, and lastly some can maybe use oils. The one used in the lab of geotechnical engineering here in UT Lahore, we use water as the confining agent. Now the question comes to mind that water, if it is surrounding the soil specimen, it may saturate the soil specimen or it may soften the soil. So to prevent all that, what we do, actually, if this is the cylindrical soil specimen, we wrap our soil specimen in a thin membrane that sticks just around it. It is extended a little bit, and on top of the soil specimen comes the porous stone. Okay, so this is the porous stone that comes on the top, and this is tied with the rubber on top of it. Similarly, a porous stone comes at the bottom. We will discuss that in detail while we are discussing it in lab, how to perform the triaxial test. But for now, we should know that the soil specimen is wrapped inside maybe I should use a different color. Let me remove this out first. Okay, let me redraw that. So if this was the soil specimen, cylindrical soil specimen, I will use a rubber membrane around it. It's extended a little bit beyond the sample length, and then we can use the porous stones at the end, porous stone at the top and porous stone at the bottom. The purpose of porous stones is to transform the load applied uniformly throughout the soil specimen. So anyways, we will tight the rubber membrane outside, so this will ensure that our soil sample is not coming in contact with the water that we are applying from the sound. Now, how to apply pressure? So that we as an engineer already know that if we want to apply pressure, then we have to place that in a confining chamber. So that's why we will place this whole assembly inside a confining chamber. So this is the loading piston that will transfer load from the top, and this is the base or the pedestal. So there is an inlet here that from which you can apply water, and here is a pressure gauge that will tell us how much pressure or sigma 3 we are being applied. So because it's a cylindrical soil specimen and we are considering this is uniform, so that means this is how, by using a glass chamber, we will apply a confining pressure on all sides of the specimen. Now this is called a sigma 3, and along with that this is the pedestal on which the specimen is placed, and from the top we apply the vertical load, we call that as sigma 1. Okay, there's one more important information here to note is that at the end of the specimen in the lower pedestal there is an inlet valve. Actually, let me zoom that up and let me remove this. So just like this. So there is a valve. This was the soil specimen, and inside the porous stone actually there is a valve and then leads outside. Okay, and then we can control the drainage. So as we are familiar with the consolidation of soil specimen, okay, so we know that once we apply pressure on a soil specimen, all that pressure would first of all increase the pore pressure inside the soil specimen, and once the pore pressure dissipated, only then the consolidation would occur. So this drainage valve, this will control that water moving out of the specimen. This is the soil specimen, and once we are increasing the load sigma 1 and also we are applying load from the side sigma 3, so it will result in an increase in pore pressure inside the soil specimen. So it is our choice, we want to drain that water out or we do not want that water to be drained out. Okay, now the same thing is explained here in a more better picture actually. So you can see this. I'll highlight that. So this is our soil specimen. Okay, the same thing is being explained here again. So this is our soil specimen, and if I change the color, let's say to pink here, so this pink thing here, this is the porous stone on top and bottom, and from this assembly here we are applying a vertical load. You see, this is the proving ring that tells us how much load we are applying, and this is the force being applied. Okay, and there should be an inlet and there should be a pressure gauge that should be telling us how much pressure is being applied. So we apply water with full pressure, so we keep filling it until the sample, this jar, we call that as jar, maybe you can call it a jar. So this jar is filled. Okay, and then we will see how much sigma is applied. Okay, and then you see, okay, sorry, this is the inlet already drawn here, so water is coming from here. So this will fill the chamber. Okay, and from the pressure gauge we will know how much pressure is being applied. So once the desired pressure has been achieved, we will close the valve, and then after we have applied the load, we will now start the test where we will start applying this major load. We call that as sigma 1 or major principal stress. Okay, and this is the drainage valve that we've already discussed, and you see that is coming directly out of the specimen, and due to the pore pressure being generated, because we know that in clays when it is loaded in, it results in increase in pore pressure. So if we want to drain it, then we will open this valve, and if we do not want to drain it, then we will close this valve. Now explaining this thing further, there are three types of triaxial test. Three types. First one is called as a UU test. The second one is called as a CU test, and lastly third one is called as a CD test. So it is a good thing to remember all these names. So to make things easier, if you can imagine the two symbols, they represent actually two stages of the test. This is the first stage and this is the second stage. In first stage is we do consolidation of the specimen. This is the first stage, and in the second stage is the shearing of the soil specimen. Okay, so the first test that says UU, this means, let's just use a thinner pen line so that it's easier to write. So it's called as unconsolidated this guy moved here. Okay, so this is unconsolidated. This is the first part, and the second says U, that means undrained. So it's a UU or unconsolidated undrained test, and then we have CU, that means consolidated and undrained test, and lastly it's a CD test, that means it's a consolidated and a drained test. So So this is the first stage of the test, and this is the second stage of the test. This is the first stage, this is the second stage. So generally, if we talk in relation to the time, so UU test generally takes up maybe, okay, a UU test generally takes up 10 to 25 minutes, maybe I might be wrong in my calculation, and this could take a day, and this takes 6 to 7 days. Okay, now let's see why this happens. So in a UU test, what we basically do is that first of all, we will bring our soil specimen from the field in form of a cylinder. If it's not, then we'll trim it accordingly, or if we have a loose sample, then we will compact it according to the field density and then convert it into a cylinder, and then place a rubber membrane around it, and then place the upper and lower porous stones, and then we will place the whole thing in the assembly. Lastly, you place the jar, and then you start the water in start filling the water inside the jar. So while we are filling the jar, we will already know that how much sigma 3 or the minor principal stress we are going to apply. Okay, so sigma 3 is called as the minor principal stress. So just a minute, what's happening? So sigma 3 is the minor principal stress. So after placing the specimen, the first thing is to apply sigma 3 or the minor principal stress. Just a minute, I don't know why my pen is not working. Hold on. Hello, let's try again. Okay, so give me a shot, and it has decided not to work. Oh, yep. So this is sigma 3. So this is the minor principal stress. Okay, so then we apply minor principal stress, and then we come to the first stage of the test. If it says unconsolidated, that means we don't have to give any time, and we start with the second stage, that is the shearing of the soil specimen. So shearing of the soil specimen, that means that we will start applying the sigma 1 or the major principal stress. Okay, so this is the second stage, that we will start applying sigma 1 or the major principal stress. Okay, so as the second stage says it's an undrained test, so that means this drainage valve will remain closed. Okay, so that means you apply load and you do not allow any pore pressure to dissipate, and then you will keep applying load until the sample fails. Okay, so this concludes the test. The second type of the test, that says CU test, that is the consolidated and the undrained triaxial testing. So in the first phase, when it says consolidated, so that means after applying sigma 3, you will have to turn on the drainage valve. Okay, so we will turn on the drainage valve and we will apply sigma 3, and then this sigma 3 and drainage valve is opened until there is no more water trickling out. Okay, because we know that sigma 3 is also a confining pressure, so that would definitely result in increase in pore pressure. So we will wait for all the pore pressure developed due to sigma 3 to dissipate, and once no more water is coming out of the drain, then we say okay, consolidation has occurred under the load of sigma 3, and then we move to the second stage of the test, that is the shearing. And because the second stage is a undrained testing, so we close the valve and then we apply the sigma 1 loading, and then we apply loading until sample fails. Okay, and the last step, that is consolidated in the drain testing. So it is done is like the previous test, that after applying sigma 3, you turn on the drainage valve, wait for all the excess pore pressure dissipate. And how we will note that? By noting the water coming out of the drainage valve. If there is no more water coming out, so that means consolidation has occurred. So in the last stage, that is the second stage, shearing stage, once it's a drain test, so what you're going to do is that we apply load in a very small increment. That means after drainage has occurred, we do not close the valve remains open throughout the test. In the CD test, the drainage valve remains open. So in the second phase, once we are shearing the specimen and the drainage valve is open, so what we do is that we apply load and then we will wait for all the excess pore pressure dissipate. Until there is no more water coming out, then we apply the second load increment and then once again wait for all the pore pressure dissipate. So that's why it takes so long, 6 to 7 days, because we know that clay has very small permeability, so definitely it's going to take a long time for all the excess pore pressure dissipate. So we keep that procedure going on until the sample fails under the loading. Okay, so generally CD test and CU test, they are both done for research purposes only because they take much longer time. Okay, and the one most commonly used in the field is a UU test. It gives us the most conservative value of the undrained shear strength of the soil. Okay, which is represented by SU, actually, undrained shear strength, or you can also represent it by CU. So it's your choice what you're going to adopt. Okay, so this summarizes the test procedures. So in our class we only perform the UU test because we don't have much time, so UU test is the one test that we do in our laboratory. Okay, now let's see if let's talk about UU test in little detail. So what we actually do is that we will take 3 samples of UU test, okay, to perform UU test. Sample number 1, sample number 2, and sample number 3. I don't know why it converted to circle, I don't know. Okay, sample number 1, sample number 2, and sample number 3. So the only difference we're going to do this in a UU test is that in first we apply sigma 3 of different value, in the second different value, and in last we apply a different value of sigma 3. Hello. So let's assume here I'm applying sigma 3 of 10 psi, and here in second specimen I am applying sigma 3 of 20 psi, and in last specimen I am applying sigma 3 of 30 psi. Okay, it's not necessary, but generally this is what we do in our lab. So this is how in each test we have to perform 3 tests on same soil specimen, with the only difference in sigma 3 or the confining pressure. In the first we apply lesser confining pressure, in the second intermediate, and in the last specimen we apply the maximum confining pressure. The example is 10, 20, and 30 psi, and then we see that how much sigma 1 it takes to fail the specimen. Okay, so this pretty much sums up everything related to the triaxial testing. It is a very important test. Okay, so let's see. Okay, so we'll come to detail in a while, but before that let's have a little roundup with the last lecture where we did the direct shear test. So here is a little comparison. So in case if we compare it, the triaxial testing with the direct shear test. Okay, so in triaxial test we have this situation, sigma 1 and sigma 3 from the sides. Just a minute, why is it not working again? Just a minute. Okay, so we were discussing the comparison between the direct shear test and triaxial test. So in a TXT we have the situation that we apply, in a TXT